Alright, this video is meant to help you understand how to find the determinant of any square matrix. Okay, we can only find determinants on square matrices. So first, just a quick review. Remember that if we have a determinant, or we want to find the determinant of a 2 by 2 matrix, we're going to do sort of this diagonal method. A times D minus C times B for the matrix that's given here. So notice in matrix ABCD with our nice brackets there, straight bars mean determinant. We can just basically subtract the diagonals. Now, a small note for you up top, if it's a 1 by 1 matrix, the only element in that matrix is the determinant of that matrix. So, for a quick review, again, pause the video now, and feel free to attempt to find the determinant of these 4 matrices. Alright, so we've got our answers here. Again, in the top part, if it's a 1 by 1 matrix, we just get that -3. Notice I've switched to those straight brackets. Sorry for a little bit of scribbling there, but straight brackets means find the determinant of. The second one came out to a 41. We've got 20 minus 20 in the third matrix here, so we get 0 back. Determinants can be 0, determinants can be negative. And then finally, at the very bottom, we've got that nice 0 working for us. So again, 0 times 4 are pretty easy. And then 2 times 3 halves would just be simply 3. So again, 0 minus 3 is -1. Again, the reason we reviewed those is finding a 2 by 2 determinant is going to be very helpful when it comes to finding determinants of larger matrices. However, if they're larger than a 2 by 2, it takes a little bit more work. Now, there is a shortcut to 3 by 3s, so feel free to look online. There's another way to do this just for 3 by 3s. Again, it doesn't work for larger. But what we call the method of minors and cofactors, notice minors and cofactors, is a great way to find the determinant of any square matrix. Okay? It comes to 2 parts. We'll talk about the minors in just a minute. But the cofactor basically is taking the minors and attaching some negatives. So you'll notice we take the minors here in the middle of the screen, okay? And we're going to multiply them by some negative numbers. How we determine those negatives depends on where they are in the matrix. So I and J, remember, are the rows and columns. So if I add the rows and columns, that makes my exponent. Now I know this looks scary, so don't worry, we'll get through this. But again, if we add our row to column, so think row 1, column 1. Well, 1 plus 1 is 2, and -1 to the second power will always be positive. So the upper left corner, that first entry, will always be a plus, which means that really we're multiplying by +1. And our minor won't change. Once we determine what those minors are, again, that number won't change. But in row 1, column 2, and right here, well, now 1 plus 2 is 3. -1 to the third would be a -1. That number will always be multiplied by a negative. So whether or not you memorize it via -1 to the power of, or you just remember the form, or the sort of form of it here, it's always going to be positive, and then sort of alternating plus, minus, plus. If we went with the second row, again, we're going to start with that negative, so it'd be minus, plus, minus. So again, if we just kind of know where those go, again, that'll come back in just a second. But let's talk about how to find the minors. To find a minor basically means we're going to pick one of the numbers in one of the rows or columns. So notice over here at the right, I've got row 1, column 1 worked out, as well as row 1, column 2. So in row 1, column 1, what I'm going to do is I'm looking at this 0. But what I'm really going to do is ignore row 1 in column 1. By looking at that 0 in row 1, column 1, I'm taking out the row 1 in the column 1. What I want to find the determinant of is what's left over. So again, looking at that 0, I'm going to ignore top row, ignore that left column, and I'm going to find the determinant of -1 times 1 and 0 times 2, or basically -1 minus 0 is -1. That makes the minor for row 1, column 1 into -1 over here. Now the same thing works. If I'm doing row 1, column 2, I'm going to ignore row 1 and column 2. I'm going to find the determinant of essentially 3, 4, 2, and 1 here. Basically ignoring that middle column, it's 3 times 1 minus 4 times 2, or basically 3 minus 8 is -5. The minor would be -5. Go ahead and take a second. Again, I'm going to pause the video now. find all of the other minors for this 3 by 3 matrix up above. Alright, we've got all the minors worked out up here. Hopefully your numbers match mine. Again, maybe just taking a look at one of them real quick. If we're looking at row 3, column 2. Again, I'm essentially ignoring row 3, ignoring column 2. I'm taking the 0 times 2 and the 3 times 1. 0 minus 3 is where I got my negative 3. Now, to make minors into cofactors, we just need to reapply those pluses and minuses that we talked about before. So again, you can go through all the negatives if you want, but basically my pattern is going to look like this. So anywhere down the main diagonal, or sort of that upward diagonal, basically we're just multiplying by positive 1, which means nothing changes. So all of my purple numbers up here, so cofactor in row 1, column 1 will be a negative 1. Again, positive 5 down here, negative 4, 4, and negative 6. But all the cofactors in these negative positions are being multiplied by a negative 1. So I'm going to take negative 5, change it into positive 5. This 2 and this negative 8 just became negative 2 and positive 8. Sorry for the handwriting there. And then on the very bottom, again, that negative 3 that we just found just became positive 3. And again, those are what we essentially call the cofactors. It's taking the minors, so sort of the determinant of the leftover numbers, and multiplying it by those negatives when needed. Only when needed. I know that seems like quite the process, but now here's the upside to that. To use minors and cofactors to find the determinant of a matrix, you don't have to have all of the rows and columns worked out. So now notice we've got all our cofactors from the previous page, but if I want to find the determinant of this matrix, all I need to do is pick either one row or one column, and then I can work them out that way. So again, to find the determinant, what I'm going to do is I'm going to pick column 3 right now. I'm going to pick this one, which means I only have to find 3 numbers. I'm going to take my 1, 2, and 1, and basically I'm going to say 1 times its cofactor. So again, I'm really looking at these numbers over here. Okay. Now what you want to remember is that means that all of these 3 numbers, though, right, came from the numbers over here at the left. Because remember, when I looked at 1, we said, okay, well, ignore row 1, ignore column 1. In fact, I'm not even going to work with column 1 with the determinants. But ignore row 1. 0 minus negative 4 became positive 4. So 0 plus 4 was where I got this 4 from. Because remember, this was also a plus, minus, plus kind of a row, right? So again, I'm just going to take that 1 times 4, and then I'm going to add it on to. Well, I'm going to take that 2, and this positive 8, and I'm going to take this 1, and this negative 6, and if I work that out, 4 plus 16 is 20, minus 6 would be 14, and that was the determinant of my matrix. Again, if this was matrix A, this would equal the determinant of matrix A. Now the beauty is you could have picked any row or column. So if I actually picked row 3, right, what if we did it that way? Notice we would have had 4 times 5. Again, we'd be going right here then, right? We'd be working this out this way. There we go. So again, 4 times 5 plus 0 times, well, that just made life easy, plus 1 times negative 6. And again, 20 plus 0 minus 6 is still 14. So notice it doesn't matter which row or column you choose. So let's try that on the next page, and we'll show you how, again, finding those cofactors is nice, but we can actually take advantage of these plus minus stuff without having to do that. We kind of take a little bit of a shortcut. So let's watch this happen. Now, we noticed in the last screen, the more we can pick a row with a 0 in it, the easier our life is going to get. So what I'm going to do is, again, pick column 3 here, purely because I've got that nice 0 in the middle. And let's see how this works. Now, here's how I would typically write this out. I'm going to take my 3, so 3 times the determinant of, Remember, I'm ignoring row 1 then. So I want 1, -1, 0, and 1. Now, this is technically plus, minus, plus. So rather than attaching that plus to the minor and making the cofactor, what I'm actually going to do is take that negative down here now. I'm just going to write it immediately. Doesn't matter if we multiplied it by the front number or by the actual minor. As long as we get that negative in the mix, we'll be good. So let's call it minus 0. Now it won't matter much because that's 0 anyway. But again, 0 would have been times -2 and 2, and 0 and 1. Again, I'm ignoring row 2. So I got my -2, 2, my 0 and 1. And then finally, positive position, so plus. We've got our 4, and we've got the, again, ignoring row 3, -2, 2, 1, -1. Go ahead and work out those 2 by 2 determinants, and let's find the answer. Then go ahead and find the determinant of the bottom matrix as well. Go ahead and try that method out. And again, I'm going to pause the video to save some time, and we'll get the answer up there in just a second. Alright, so let's take a look real quick here. Again, all the determinants of the 2 by 2s, and the blue I've got worked out up top here. Notice that the last one happened to come out to 0. The middle one really didn't matter, so I didn't even work it out. We get 0 times that determinant is going to be 0 anyways. And over here at the right, that makes for 3 minus 0 plus 0 is 3. Down at the bottom, the same sort of thing kind of happened. We had a nice row here, again 1, 0, and 0. So I went ahead and picked that one. Notice that means it's a plus, minus, plus. Then we've got all of our determinants, our 2 by 2s, all set up, which means the last two, though, became out to both 0. The first one also had a 0 mixed in there. Notice on that upper triangle, so 1, or diagonal, I should say, not triangle, diagonal. 1 times -5 becomes -5. Now, that last one also gives us a way to say, hey, this isn't so scary anymore. We'll just do a little bit of work, and hey, it's not so bad. And in fact, if we can take advantage of those zeros, life gets really, really good. As you noticed on this example down here, with the extra zeros in there, we could actually get rid of doing most of the work. And that's why there's a great shortcut when you're talking about lower triangular, upper triangular, or diagonal matrices. A lower triangular matrix means there's just numbers all over the lower side of this thing, but notice all the zeros. And if we do that, essentially we're going to have 4 times its determinant, and then a couple of zeros. So 4 times the determinant of sort of the minor of that spot. So -3 times -5 is going to be 15, right? In fact, we can even just go parentheses on here. Essentially, we're just looking at this part. So we're going to say 15. And notice, because there's another 0 in here as well, right? That means that technically this also becomes 0, so -0. But then again, we're plus a -0 and plus another 0 because of these top two numbers. We don't really need the other minors. Notice what really happens. We just end up with 60, which essentially was 4 times -3 times -5. Right? Our -3 and -5 make our 15 right here, and we end up multiplying by that 4 in the upper corner there. Well, the same thing will happen if we have an upper triangular matrix. Again, if we kind of just pick this column here, we get that double 0 thing going on, or you could go with the row 3, get that double 0 thing going on. But essentially, it just comes down to -2 times 7 times 3, and you'll end up with -42. And the same again with even a larger matrix, even though we would be saying, okay, let's go with row 1. So we've got 3. Notice all the other minors are going to be zeros. But now, when we look at that leftover set of 4, why don't we pick these 4, right? Again, we're going to get a lot of zeros and a 2. And then a lot of zeros and a lot of zeros. Basically, what it's going to come down to is just multiplying 3 times 2 times -1 times 5 times -4, which is 6, -6 makes -30, makes positive 120, and we've got our answer. Good luck finding determinants. I hope Minors and Cofactors works well for you, and if you have any questions, make sure you talk to your teacher. Have a great day.